Have you ever noticed how Formula One cars run on tires that look completely bare? No tread marks, no grooves, nothing like the rubber you see on an everyday car. Just smooth, flawless circles of black wrapped around those enormous wheels. At first glance, it almost feels like something is missing, like the tires were still waiting for the finishing touches before race day. But that polished, bald look isn't an accident. It's one of the cleverest ideas in all of motorsport engineering. And there's a very specific reason why Formula One teams insist on using these strange-looking tires. A reason that goes way beyond appearances. You might assume the smooth surface is simply about going faster in a straight line, or maybe saving weight. But the truth is much more interesting. Because if you've ever wondered how an F1 car can brake from over 330 kilometers per hour down to a crawl in just a few seconds, or stick to the track through corners that would fling most cars straight into the barriers, you'll find the answer hiding right here in this unusual tire design. But before we get into exactly why these slicks behave the way they do, it helps to understand where they came from. Because Formula One tires didn't always look like this. Back in the 1950s and 60s, racing rubber was tall, narrow, and deeply treaded, almost like something you'd see on a motorcycle. In those days, tires weren't engineered for ultimate grip. They were built to survive the brutal distance of a Grand Prix without tearing themselves apart. Durability mattered more than outright performance. The compounds were rock hard, the construction was stiff, and when the rain started falling, you could basically count on chaos. Drivers had to rely on instinct and courage just to keep the car pointing in the right direction. But as the cars grew faster and the demands of racing intensified, tire technology was forced to evolve. The real breakthrough came in the late 1960s, when Goodyear developed the first slick tire for Formula One. This single innovation flipped the sport upside down. Engineers suddenly realized that by changing the tire's surface, they could transform everything about how a car behaved. It was a moment that redefined racing forever and set the stage for a completely new era of performance. And in a moment, we'll explore exactly how that change unlocked the secret behind these tires' strange, counterintuitive behavior. From the moment slick tires appeared in Formula One, everything about racing began to evolve at lightning speed. The breakthrough happened in 1971, when Goodyear started testing completely smooth tires on F1 cars. Until then, most racing tires still had shallow treads cut into them, remnants of an era when road and race tires were not so different. Teams had been running cross-ply construction, narrow widths, and rubber compounds that prioritized durability over raw grip. When Goodyear removed the tread pattern entirely, teams quickly realized they had stumbled onto something radical. In 1971, Jackie Stewart tested these new slicks on his Tyrrell 003 and immediately saw lap times tumble by more than a second per lap. For reference, that's the kind of performance jump teams today can spend an entire season chasing through aerodynamics alone. Once slicks proved themselves, it kicked off a technological arms race. Throughout the 1970s and especially in the turbocharged 1980s, tire design became as critical as engine power. Rear tires exploded in width. Some cars, like the 1986 Brabham BT55, ran rear slicks up to 18 inches wide. If you look at photos of Alain Prost's McLaren MP42 or Nelson Piquet's BMW-powered Brabham, you'll see the tires are so broad they look almost cartoonish, like giant rubber rollers bolted onto the rear axle. There was a simple reason for this. Turbo engines were producing over 1,000 horsepower in qualifying trim. Even with all that power, teams had no traction control. You had to rely purely on mechanical grip, the tire's contact patch pressing into the asphalt, to keep the car under control when accelerating out of corners. Meanwhile, the tire companies were engaged in their own ferocious rivalry. Goodyear, Michelin, Dunlop, and later Bridgestone were all in the sport, constantly experimenting with new compounds, carcass constructions, and sidewall stiffness. Michelin, in particular, became famous for pioneering radial construction in F1, which allowed better stability and heat distribution compared to traditional crossply designs. It wasn't just about lap times. The right tire could transform how a driver managed a stint. Some compounds were engineered to last almost an entire Grand Prix distance, while others were incredibly soft and sticky, designed for just a few laps of maximum attack in qualifying. This period came to be known as the Tire Wars, because every manufacturer was trying to outsmart the others by delivering tiny performance gains. A compound that heated up 2 degrees faster, or a sidewall that flexed slightly less under load, could decide whether you were starting on pole or mired in the midfield. And for the teams and drivers, the stakes couldn't have been higher. You only had to look at the differences in performance from weekend to weekend. Sometimes Michelin would dominate, sometimes Goodyear would strike back, to realize that slick tires weren't just another component. They were the secret weapon that could win you a championship or end your season in frustration. But as the 1990s gave way to the 2000s, Formula One started to change direction. The tire wars, while thrilling, were becoming unsustainable. Developing dozens of compounds and constructions every season cost tens of millions. Smaller teams struggled to keep up, and the sport's leadership began to worry that all this competition was making F1 too unpredictable and too expensive. By the mid-2000s, the FIA decided it was time to rein things in. In 2007, Formula One moved to a single tire supplier, Bridgestone.
Bridgestone is taking up the challenge of Formula One.
For the first time in decades, every team ran the same rubber. No more secret test compounds, no more last-minute overnight shipments of new spec tires. Bridgestone's approach emphasized consistency and durability, and their compounds were famously tough. Some drivers complained the tires were too hard and lacked the drama of the old days. But they were reliable, and with everyone on the same playing field, teams could focus more on car development rather than outspending rivals in the tire war. Then, in 2011, Bridgestone exited and Pirelli took over. But Pirelli came in with a different philosophy. They were instructed to create tires that would degrade quickly. The idea was to make races more exciting by forcing teams to manage tire wear and plan extra pit stops. These designed-to-degrade tires sparked controversy immediately. Fans and drivers were shocked by how fast the performance would drop off. Sometimes just 10 or 15 laps of peak grip before the tires started to feel like driving on marbles. But whether you loved or hated them, these new compounds achieved exactly what the FIA wanted: more strategic variety, more overtakes, and more unpredictability. Despite all these changes, regulations, compounds, suppliers, one thing never shifted. When conditions are dry, slicks remained supreme. The reason is still the same as it was when Goodyear rolled out the first prototypes in the 1970s. No tread means maximum surface area. Maximum surface area means maximum friction, and maximum friction means lap times that defy belief. But there's a trade-off. Racing slicks operate within a razor-thin temperature window, usually between 90 degrees and 110 degrees Celsius. Too cold, and the rubber feels like ice. Too hot, and the compound starts to blister, or grains, shedding little bits of rubber and losing grip by the corner. It's why drivers weave from side to side behind a safety car, because if the tires cool down just a little, they can't generate the friction needed to stick to the tarmac. These tires are some of the most sophisticated in all of motorsport, but they're also divas, unforgiving, temperamental, and absolutely essential for going fast. Yet, as brilliant as slicks are, the moment the rain starts falling, their greatest strength becomes a massive liability. A slick tire in the wet is like sprinting across a polished tile floor in socks, utterly unpredictable and almost impossible to control. That's the moment grooves make their return to Formula One, when slicks finally meet their match and the fight for grip takes on a whole new dimension. Because as soon as the rain begins to fall, even a light drizzle, everything you just learned about slick tires gets turned completely upside down. The same smooth surface that makes them unbeatable on dry tarmac becomes their biggest liability. Slicks in the wet are like ballet shoes on an ice rink. No channels to clear water, no texture to bite into the road, just a flat slab of rubber, gliding over puddles with nowhere to go but straight ahead, whether you like it or not. Slick tires work like a dream only when the track is bone dry. As soon as there's water, it's like watching a ballerina in perfect control suddenly step onto an ice rink. Imagine that at 300 kilometers an hour. Slick tires are completely smooth, no channels, no ridges, no grooves to push water aside. So instead of slicing through puddles, the tire rides up on top of them. It's called aquaplaning, and it's one of the scariest sensations a driver can experience. In that moment, you're not driving anymore. You're skimming across a wet film with zero control over where the car will go. It doesn't take much. Aquaplaning can start at just 60 kilometers per hour. At 280, it's like launching a missile with no steering. That's why, as soon as the rain comes, teams rush to bolt on either intermediate or full wet tires, each built specifically to handle water. Full wets are absolute marvels of engineering. They're sculpted with deep grooves that channel water away from the contact patch. And it's not just a little moisture. These tires can eject up to 85 liters of water per second. Multiply that by 4 wheels and you're looking at 340 liters, enough to fill a garden pond every single second. When you watch an onboard camera during a wet race, seeing drivers buried in a cloud of spray chasing the blinking rain light of the car ahead, hoping they're braking in the right place, that's when you understand. Grooves aren't about performance anymore. They're about survival. Try running slicks in those conditions and you'll find out quickly why no one does. It's like turning up to a basketball court wearing polished dress shoes. You might look sharp, but you're going to end up flat on your back. Wet tires, on the other hand, are like rugged hiking boots. Their channels cut through standing water, forcing it away so the rubber can stay locked onto the asphalt. But there's always a compromise. Those grooves that save you in the rain also mean less rubber touching the road in the dry. Less surface area means less grip, more squirming, and slower lap times. So when the rain eases off and the racing line starts to dry, teams switch to intermediates, green mark tires with shallower grooves designed to handle damp patches, while still delivering some of the slick's direct feel. But as soon as the surface is fully dry, there's no debate. Slicks go back on, every time. Because in Formula One, grip is the most precious currency there is. It buys you lap time, confidence, and the chance to pull off moves that should be impossible. And there's another reason smooth tires rule the dry, one you might not expect. It's not just about maximizing traction, it's about predictability. Treaded tires flex and squirm. Those rubber blocks deform under load and move around unpredictably. But slicks? They stay consistent. The driver always knows exactly when they're about to grip or let go. That predictability is everything when you're threading the car through a high-speed chicane, trusting it will do the same thing lap after lap. So yes, F1 tires are smooth as glass. And that's not a design flaw, it's the whole point. Because when you're chasing tenths of a second, cornering at 5 Gs, and driving the fastest cars on Earth right up to the edge of chaos, you don't want chunky grooves. You want ballet slippers. Okay, so now we understand why F1 tires are smooth. But how are they actually made? And why are they some of the most extreme pieces of engineering in all of motorsport? Let's start at the beginning, before the tires even exist as something you can touch. At Pirelli's headquarters in Milan, more than 150 research engineers are dedicated solely to Formula One. Their work starts in high-tech physics and chemistry labs, where they experiment with hundreds of different materials. Each compound is a proprietary blend: synthetic rubber, carbon black, resins, polymers, oils, mixed in precise ratios nobody outside Pirelli is allowed to know. Even the F1 teams themselves never get the full recipe. From there, the process moves to virtual modeling. Before a single prototype is ever built, engineers simulate how a tire will behave under massive downforce, lateral G-forces exceeding 5G, and temperatures that can soar past 150 degrees Celsius. Once they're confident in the simulation, it's time to create a physical prototype. This is done in Pirelli's dedicated motorsport factories, one in Romania and a backup facility in Turkey. The compounds themselves are prepared at the company's Settimo Torinese plant in Italy, which specializes in high-performance rubber production. But simply molding the rubber into something round isn't nearly enough. Inside every F1 tire, there are 18 structural components, from the inner liner to steel belts, Kevlar reinforcements, and nylon cords. These layers work together to resist deformation under load while still providing flexibility and feel. Here's a way to picture it. The outer rubber you see is just the skin. Underneath is a skeleton and a nervous system that dictate how the tire flexes and grips. Once the internal structure and the outer compounds are ready, the build process begins in earnest. Think of it like assembling a layer cake, except each layer has to handle cornering forces that would rip an ordinary road tire apart in seconds. Specialized technicians work in parallel. One team assembles the shoulder and carcass, while another creates the belt and tread package. After assembly, the tire isn't finished yet. It has to be vulcanized, basically baked in a mold. This step does 3 things. It fuses all the layers into a single cohesive structure. It locks in the tread pattern for wets and intermediates, or leaves the surface perfectly smooth for slicks. It seals in the barcode, a unique identifier that acts like a tire's passport, tracking its entire life from the factory to the checkered flag. Even after vulcanization, the scrutiny continues. A visual inspection for defects, a weight check to ensure perfect balance, an X-ray scan that peers inside to confirm structural integrity, and if you think that sounds thorough, it gets tougher still. Random tires are pulled aside for destructive testing, literally torn apart in labs to verify they meet the standards of safety and performance. It's an astonishing amount of effort for something that, in a race, might last only 100 kilometers before it falls off a performance cliff. But that's the paradox of F1. The softer and stickier the tire, the faster it is, and the faster it destroys itself. And that's only the beginning, because once these tires leave the lab and enter the real world of 300 km/h racing, their story gets even more intense. Once the tires have passed every lab and factory test, they finally make their way to the circuits, where the real torture begins. Every Grand Prix weekend, around 1,800 tires are transported to the paddock. That's over 16,000 kilograms of rubber, the weight of about 13 McLaren Senna hypercars. Each tire is carefully cataloged, scanned, and matched to specific allocations for each team. And even then, there's still just potential. To unlock their performance, teams use tire blankets, thick heating wraps that bring the rubber up to around 80 degrees Celsius before the car ever leaves the garage. Without preheating, a cold slick behaves more like hard plastic than soft rubber. Drivers compare it to trying to skate across polished tile in socks, a recipe for instant disaster. But even warm, these tires are shockingly fragile. F1 compounds are designed to operate in a very narrow temperature window, usually between 90 degrees Celsius and 110 degrees Celsius for dry compounds. Fall below that and the rubber hardens, losing grip. Go above it and you get blistering, where pockets of superheated rubber bubble and tear away. The tires also endure punishment that's almost hard to believe. During development, Pirelli tests them at simulated speeds up to 450 kilometers per hour, far faster than an F1 car will ever actually go. When it comes to curb impact, they simulate striking a curb at 260 kilometers per hour, the kind of shock that would shatter normal tires. And the temperatures? Under braking or wheel spin, tread surfaces can spike past 150 degrees Celsius, hot enough to cook meat. This is why drivers talk so much about tire management. Every time you lock up under braking, every time you spin the wheels on corner exit, you're effectively tearing microscopic chunks of rubber away. Over time, that leads to graining, when little balls of rubber build up on the surface, reducing grip. Blistering, when heat damages the rubber internally. Thermal degradation, when the compound loses its chemical integrity altogether. And that's why strategy is everything. Do you start on soft tires, aiming to sprint ahead but risking an early pit stop? Do you gamble on hards, hoping to outlast your rivals? Or do you dance on the knife's edge of changing conditions, switching to intermediates at exactly the right moment as the rain arrives? We've seen the difference tire choices make. Lewis Hamilton in Turkey 2020 nursing worn intermediates across a greasy track to seal a world championship. Lando Norris in Russia 2021 staying on slicks one lap too long as the rain fell, turning near certain victory into heartbreak. Even the construction of the tire affects performance. F1 tires are directional and asymmetric, meaning they're designed to rotate only one way and have specific inside and outside edges. Inside, steel belts and Kevlar reinforcements create stiffness, while still allowing controlled flex. For all their sophistication, these tires are ultimately temporary. On high degradation tracks, a soft compound can last as little as 15 laps, about 100 kilometers, before it's too slow to keep. But in that short lifespan, they do something no other part of the car can. They connect over 1,000 horsepower to the asphalt through just 4 postcard-sized contact patches. And that's why drivers call it an art. Because the fastest lap times don't just come from pushing flat out. They come from knowing when to push and when to back off. It's why some drivers, like Sergio Perez, have earned reputations as tire whisperers, stretching stints longer than anyone else, waiting for the race to come to them. Because in the end, these slick, bald, strangely simple-looking tires are anything but simple. They're a blend of physics, chemistry, craftsmanship, and driver intuition, all working together to keep a Formula One car stuck to the tarmac at speeds that defy belief. And that's why when you watch an F1 car glide around a corner at 5G, you're not just seeing talent or engineering. You're seeing a dance between rubber and road. And it all starts with a tire. So the next time you watch an F1 car disappear into turn 1, remember, those smooth, slick tires aren't just bits of rubber. They're the product of hundreds of engineers, thousands of hours, and more science and precision than most people will ever realize. They define the race strategy. They dictate the grip. They decide whether a driver clings to the apex or skids helplessly into the runoff. 4 contact patches, each barely bigger than a postcard, are all that connect 1,000 horsepower to the ground. And in a sport obsessed with speed, that tiny sliver of rubber is often the difference between control and chaos. Because in Formula One, everything starts and ends with the tires.